How can a fighter jet fly at more than twice the speed of sound, pull brutal maneuvers, and still remain a frontline combat aircraft after nearly 50 years? Meet the F-16 Fighting Falcon, an icon of modern air power. In the next few minutes, we'll peel back the skin and watch the engineering breathe. The story begins in the United States during the 1970s, when General Dynamics designed a lightweight fighter focused on agility and value. Later, Lockheed Martin acquired that aircraft division and carried the program forward. The result is a jet that many nations could afford, fly hard, and keep ready day after day. Why did so many air forces choose it? The Falcon hits a rare balance: strong performance, lower operating costs, high reliability, and maintainability built into the airframe. And crucially, it never stopped evolving. New radars, sensors, weapons, and computers kept the platform relevant as threats changed and missions expanded. To understand how the F-16 flies, start with the four forces. Lift pushes up, weight pulls down, thrust drives forward, and drag resists motion. In steady flight, these balance like a tightrope. Change one, and the aircraft accelerates, climbs, dives, or turns, sometimes violently by design. The Falcon's wing is a compact swept design optimized for high-energy maneuvering. At speed, it generates lift efficiently. At high angles of attack, vortex flow helps keep the wing working longer. In a hard turn, you can almost see the air being sculpted, pressure dropping above the wing, lift rising in response. But the real magic is control. The F-16 was built with relaxed static stability, meaning it's naturally a bit eager to wander, great for agility, but demanding for a human. So a digital fly-by-wire system constantly nudges the control surfaces, making thousands of corrections to keep the jet stable and responsive. Look closer at the moving pieces. Elevators trim pitch, the rudder commands yaw, and the flaperons blend roll control with lift. Leading-edge flaps adjust the wing's shape to delay stall and improve handling across the envelope. Together, they let the aircraft change attitude fast while staying controllable. All that maneuvering demands power, so let's cut into the engine. Air rushes through the intake and into the compressor, where rotating blades squeeze it to higher pressure. That compressed air becomes the foundation for everything that follows, because in a jet engine, pressure is potential energy waiting to be released. Next comes combustion. Fuel is sprayed into the high-pressure air and ignited, creating a hot, expanding flow. That blast drives the turbine, stages of blades extracting just enough energy to keep the compressor spinning. What remains surges rearward, and the nozzle shapes that flow into thrust you can feel in your chest. Need even more? The afterburner injects fuel downstream of the turbine, where oxygen still remains. When it lights, the exhaust temperature and volume jump, and thrust spikes dramatically at the cost of fuel. With that extra push, the F-16 can sprint past Mach 2, leaving a shimmering trail of heat behind it. Now step into the cockpit. Modernized Falcons wear a glass cockpit. Multifunction displays consolidate radar, maps, and weapons data. The head-up display projects critical flight cues directly into the pilot's forward view, so eyes stay outside. It's a human-machine partnership built for speed, clarity, and survival. Control philosophy is just as deliberate. The F-16 uses a side-stick controller, reducing pilot workload during high-G turns, and HOTAS keeps hands on throttle and stick. In a fast merge, tiny inputs command the computer, which translates intention into precisely timed surface deflections, smooth, quick, and repeatable. Because it's multirole, the Falcon can shift from air to ground in the same sortie. It carries missiles for dogfights, bombs for precision strike, and sensors for finding targets in bad weather or at night. The jet isn't defined by one mission, it's defined by how fast it can change roles. On the wings, you'll find familiar tools of combat: AIM-9 Sidewinders for close-range shots, AIM-120 AMRAAMs for beyond visual range, and JDAMs for GPS-guided precision. Add external fuel tanks for reach and targeting pods for identification. Each store changes drag and balance, so planning is engineering too. So why is it still so successful? The airframe is light, the engine is strong, and the handling is legendary. Its combat record proved the concept, and its upgrade path kept the jet current: new avionics, sensors, and data links. More than 25 countries fly variants, each tailored to local needs and doctrine.